Let's look into one more question related to viscosity. So if I say that I have two set of stationary plates, means the velocity at both the plates will be 0, and it is desired that a small plate, let me move it, a small plate has to move at a velocity of 2 meter per second such that it is at a distance of 4 mm from one plate and at a distance of say 10 mm from another plate. It has also been provided that the area of the plate is 4, let's change the area, say let's put it 8 meter square. Further, the viscosity of the liquid is given as 3 Newton second per meter square. This is all what has been provided, and I am being asked that what is the force required to move this plate at a given speed in the given condition, right? So I'm being asked that what is the force required. So if you look at the system can be divided into two parts. So if I want to divide it, I can divide it from here and look this as problem 1 and look this as problem 2. So from problem 1, when this plate is moving, there will be some shear stress in this direction, that will be tau 1, and from this direction there will be some shear stress tau 2. So these both of the shear stress will be acting on two different sides of the plate. So the total shear stress will be tau 1 plus tau 2, and the total force will be given as tau 1 plus tau 2 into total area of the plate. This is the basic idea how we will be solving this question. If you can solve it, good, go ahead. If not, then look how I'm solving it. So I know that the force, total force, is actually equal to shear stress into area. Now in this system, the shear stress is acted by two sides, that is from side 1 and side 2. So this is tau 1 plus tau 2 into area. How to find tau 1? So for tau 1, I have to put mu du upon dy. So mu is viscosity. So everything is very clear over here. You are being provided mu is 3. The change in velocity, see, this plate is at velocity 0, this plate is at velocity 2, so I can write 2 minus 0, and the distance is 4 into 10 raised to the power minus 3, right? So there will be some value, I can write it. This is 1.5 into 10 raised to the power 3 Newton per meter square. Similarly, tau 2 can be found as mu du upon dy. This will be, see, viscosity remains same because we are in the same liquid. Du, again the change in velocity, this plate is at 0, other plate is at 2, 2 minus 0, and the distance between the plate is 10 into 10 raised to the power minus 3. So this is 6 divided by 10, 0.6 into 10 raised to the power 3 Newton per meter square. What we observe over here, that as the distance is increasing, the shear stress on acting on the plate is decreasing. So if I want to find the total shear stress, it will be tau 1 plus tau 2, which will be 1.5 into 10 raised to the power 3 plus 0.6 into 10 raised to the power 3. This will be 2.1 into 10 raised to the power 3 Newton per meter square. Force is equal to tau into area. This will be 2.1 into 10 raised to the power 3 into, what is the area of the plate? 8 meter square into 8. So this is 16.8 into 10 raised to the power 3 Newton, or 16.8 kilonewton, right? This is your answer. So force is actually 16.8 kilonewton. What sort of jugglery you can do over here is that, say these plates instead of being horizontal are placed vertical, right? I won't be solving it, you can solve it yourself. And the plate over here is moving in this upward direction. So this is the force. Everything will go the same way we have done. When we talk about vertical, there will be an additional component of weight being added. Weight can be given you in any form. Either it will, a straightforward weight is given, or the dimension are given, and from dimension you multiply density of this plate, you get the weight. So in that condition, the force which you will be requiring will be tau 1 plus tau 2 into area plus the weight. So this will be the solution in that case. You can solve it. So if you say that the weight is, say, 5 kilonewton, in this condition rest all remains same, so the force will be actually equal to 16.8 plus 5, which is equal to 21.8 kilonewton. That's all.